brand new aircraft has already forced airlines to rewrite routes, delay billion-dollar fleet plans, and quietly prepare for a shift passengers still don't see yet. That aircraft is the Boeing 777X, and even before entering service, it has attracted more than 600 orders. But here is the reality most people miss. This plane was supposed to fly passengers in 2020. It is now expected no earlier than 2027. And yet airlines are still waiting, because if it works, it changes everything. For decades, long-haul aviation was dominated by giants like the Airbus A380 and the Boeing 747. These aircraft were built around a simple idea: move as many people as possible between major hub airports. But that model started breaking down. Airlines struggled to fill 500 crew seats consistently, and when demand dropped even slightly, profits collapsed. That is exactly why production of the A380 ended in 2021, and why the 747 is no longer the backbone of modern fleets. The industry shifted away from size toward efficiency. That shift accelerated with the Boeing 787 Dreamliner. It proved that smaller, fuel-efficient aircraft could open direct long-distance routes without relying on massive hubs. Airlines could now connect cities that previously required stopovers. But the 787 had limits. It could not fully replace high-capacity aircraft on the busiest routes. Airlines still needed something bigger, but not inefficient. That gap is exactly where the Boeing 777X comes in. The 777X is the largest twin-engine passenger aircraft ever built. The main variant, the 7779, carries around 26 passengers in a typical configuration and can fly more than 728.5 nautical miles. That combination matters because it allows airlines to operate high-demand routes with fewer flights while still maintaining strong fuel efficiency. Compared to older aircraft like the 777-300er, Boeing claims up to 20% lower fuel burn and emissions. That is not a small improvement. On long-haul routes, fuel is one of the biggest costs, so even a 10% improvement can translate into millions of dollars saved per aircraft every year. The biggest reason behind that efficiency is the engine. The GE9X engine is the largest commercial jet engine ever built, with a fan diameter of about 13.4 inches. These engines produce over 100 pounds of thrust, but more importantly, they move massive amounts of air more efficiently. Instead of relying on speed, they rely on volume, which reduces fuel consumption. However, this same engine has also become one of the biggest sources of delay. In 2024 and 26, durability issues were discovered in key components, forcing additional testing and slowing certification. This is the trade-off. The technology that makes the aircraft revolutionary is also what makes it difficult to finish. Then there is the most visible innovation: the wings. The 777X has a wingspan of about 235 feet, making it larger than most aircraft in its class. But airports around the world are not designed for wings that large. Boeing's solution was something never used on a commercial airliner before: folding wingtips. On the ground, the wings fold up, reducing the span to about 213 feet, allowing the aircraft to use existing airport gates. The air, they extend fully, improving aerodynamic efficiency and reducing drag. This design alone contributes to measurable fuel savings and allows the aircraft to operate globally without requiring airport upgrades. Inside the cabin, the aircraft builds on improvements introduced by the 787. Lower cabin altitude equivalent to about 6,000 feet, higher humidity, larger windows, and quieter interiors all reduce passenger fatigue on long flights. These are not marketing features. They directly impact how passengers feel after 10 to 15 hours in the air, which is why airlines prioritize them on premium routes. But despite all these advantages, the program has faced serious problems. In 2019, a structural test resulted in a fuselage failure under extreme pressure conditions. In 2020, a test flight experienced an uncommanded pitch event, raising concerns with regulators. In 2024, cracks were discovered in thrust link components connecting the engines to the wings, grounding test aircraft temporarily. These are not minor issues. Each one adds months or years to certification. After the Boeing 737 MAX crashes, regulators like the FAA significantly increased oversight, making certification slower and more demanding than ever before. Financially, the impact has been massive. The program has accumulated more than $15 billion in cost overruns. Boeing has already indicated it may not recover development costs on the first hundreds of aircraft produced. This turns the 777X into one of the most expensive bets in aviation history. Yet airlines have not walked away. Major carriers continue to hold orders because there is no direct replacement that offers the same combination of capacity and efficiency. The closest competitor is the Airbus A380. It is already in service, reliable and efficient, but it carries fewer passengers, typically around 350 to 300. That difference of 50 to 70 seats becomes significant on high-demand routes. More seats mean more revenue per flight, especially when combined with strong cargo capacity, which is another area where the 777X has an advantage due to its wider fuselage. This is where the real battle is happening. Airbus is offering certainty. Boeing is offering potential. Airlines are choosing between a proven aircraft they can use today and a more powerful aircraft that could reshape their future operations. That is why, even with delays, the 777X still holds hundreds of orders. Right now, more than 20 aircraft have already been built and are sitting in storage waiting for certification. Boeing continues testing, with thousands of flight hours completed across extreme conditions. The goal is clear: achieve certification, begin deliveries, and finally prove that the aircraft can perform as promised in real airline service. If it succeeds, the impact will be immediate. Airlines will replace older 777 and 747 fleets faster. More direct long-haul routes will open. Operating costs on major routes will drop. Ticket pricing dynamics could shift over time as efficiency improves. But if further delays continue or technical issues persist, the aircraft risks becoming a symbol of overambition rather than innovation. That is the reality of the Boeing 777X. It is not just another airplane. It is the most advanced long-haul aircraft ever built, designed to replace an entire generation of jets. But it is also one of the most delayed and expensive programs in aviation history, and right now, the entire industry is waiting for the same answer. Not whether it is powerful enough, but whether it will finally arrive.